Hi guys, in this video I will show you how to convert decimal numbers into binary numbers and binary numbers into decimal numbers. So first of all we are going to convert 25 decimal numbers into binary number. So when we converting decimal number into binary number, we have to divide it by 2. When we divide the 25 by 2, it gives us 12 quotient, and it gives us 1 as a remainder. So the first remainder, the very first remainder we will call LSB or least significant bit. What? Least significant bit. After that, the first quotient is divided by 2 again. So when the first quotient is divided by 2, the second quotient we obtain and the second remainder we obtain, and then we will divide the 6 by 2 and the third quotient we obtain and the third remainder we obtain from this. So proceeding this process,
when the
dividend and the divider, when the dividend becomes lower than the divider, so we stop here because we get a quotient with 0 and some remainders here, some remainder. So here we convert 25 to the binary number, and it is in the decimal base 10. Okay, so when we divide 25 by 2, it gives 12 quotient and 1 remainder. When we divide 12 by 2, it gives 6 quotient and 0 remainder. When we divide 6 by 2, it gives 3 quotient and 0 remainder. When we divide 3 by 2, it gives 1 remainder, 1 quotient and 1 remainder. When we divide 1 by 2, it gives 0 quotient and 1 remainder. So further proceeding, it is not possible to divide 0 by 2. This all is the obtained binary number. The last one digit is called most significant bit, MSB. So from the most significant bit towards the least significant bit, we write this as a binary number 11001. So therefore 25 to the base 10 is equal to 11011 to the base 10. 25 to the base 10 is equal to 11001 to the base 2. Okay, now in the next slide we will go to convert binary number back to decimal. So let's go. Binary to decimal conversion. So in this slide we will convert back 11001 to decimal. 11001 is in the base of 2. So we will convert it to decimal. So in this method we are taking the weight of each binary number. So as in the decimal number, the weight of the first decimal number is multiplied 10 to the base 0. The second number is we multiply 10 to the power 1, 10 to the power 0, 10 to the power 1, 10 to the power 2. Here in this case, it is similar for the binary numbers. When we convert binary number into decimal number, we multiply each binary number by the weight, by its weight. How we multiply it? Here, the weight of the first digit, the least significant digit, or the least significant bit, sorry. In binary number we call it bit. So here the least significant bit we multiply it by 2 to the power 0. So 2 to the power 0 is equal to 1 multiplied by 1, it is equal to 1, or here we call the weight of this 1. The next significant bit, we multiply it by 2 raised to the power 1. So the weight of this is called 2. The power of 2 is called the weight of this, the relative number. So 2 raised to the power 1 is equal to 2. So this is the weight of the second binary bit. 2 multiplied by 0 is equal to 0. Okay. Now the third binary bit is multiplied by 2. 2 raised to the power 2. So 2 raised to the power 2 is equal to 4. So 4 is the weight of the third binary number, and the third binary number is equal to 4 multiplied by 0 is equal to 0. And so on, we multiply the fourth binary number by 8. The weight of this is 8. So 8 multiplied by 1 is equal to 8. And the fifth binary number weight is 16. So we multiply it by 1. And 16 multiplied by 1 is equal to 16. And after multiplying each number, we sum of all the numbers. After multiplying each number, we sum of all the numbers. When we sum these numbers, it gives us it should give us 25 back. So 16 plus 8 is equal to 24, plus 0 is equal to 24, plus 0 is equal to 24, plus 1. Here this is 1. Plus 1 is equal to 24, plus 1 is equal to 25. So it give back us 25 to the base 10. So we proved that when we convert decimal into binary, we will divide it by 2 and we will write all the remainders from most significant bit to the least significant bit side. And when we convert back binary into decimal, we will multiply each binary bit by its weight, and we will sum up each of these numbers. When we multiply each binary number by its weight, we will write it here. Okay, and then we will add it or sum of these numbers. So it will convert to the decimal number to the base 10. So until now it is enough. We'll see you in the next lecture. Bye bye.